G'day everyone, Riley here from RD Auto Electrics and welcome back to the channel. On this beautiful, brisk, cold morning, you're tuning into the latest episode in our Tech Talk series, and we are going to title this one, Power System Problems. Now, before you jump into the comments, we just wanted to mention that this is not a factory fitted power system, nothing to do with Jayco. This is a power system that was fitted aftermarket, and by the looks of things, we're presuming that it is a DIY install. This van came into us recently to have a couple of problems checked out. Now, the owners purchased this caravan secondhand. They've taken it away for a trip. They've had a number of frustrating issues with the power system and brought it into us for a diagnosis and to have these problems resolved. Now, the reason that we thought we would take the opportunity to film this episode is a lot of the problems that we've come across in this caravan are what we believe to be the most common misconceptions and issues with power systems, and in particular lithium power systems running inverters. This episode is also really going to help you to see why we recommend engaging a professional when it comes to the design, the supply and installation of your lithium power system upgrade. Because as you're going to see shortly, there's issues with how the system's been designed, the products that have been supplied, and how the installation has been carried out. So this is why we strongly do not recommend DIY installations. And not only do we recommend engaging a professional, but also someone that specifically specializes in lithium power system upgrades, because there is a lot that goes into putting a system like this together that's going to be safe, reliable and easy to use. So let's jump in and have a look at the system and have a look at what we found. Alrighty, now I'm not sure what the visibility is like for you guys on your end, because it is a pretty tight space in here, but I've tried to get sort of a good shot of the power system so you can get a bit of an idea on what's going on. This power system is located under one of the kids' bunks, and as you're going to see shortly, there's so many issues going on with this power system that an electrical fire is definitely not out of the question, and to have something like this going on under a child's bed is mind-blowing and definitely not something you want, and it really makes you appreciate the seriousness of this situation and why we are so passionate about the fact that a job like this, no matter where its location is, needs to be done professionally. So I think one of the most common misconceptions that we see, and one of the most common questions that we get asked is, my van's come factory fitted with a couple of lithium batteries and I've bought an inverter and I just want to slap it in, good to go. So how much to get that done? How long's a piece of string is normally my answer. In this case, this is definitely one of the most common issues that we see. So what we have here is a factory fitted power system from Jayco, which includes your two 120 amp lithium batteries. These are a Sphere brand, but we see all different brands. So 240 amp hours of lithium in total. And then what we have at the back is a 2000 watt inverter. Now, this was not fitted from factory. This was fitted by the previous owner. Now, the issue with this is that on a lithium battery, you have two ratings. You have an amp hour rating, which is the power that the battery can store. And then you have a discharge rating, which is how much you can discharge out of that battery in a 1 hour period. Now, when you link two lithium batteries in parallel, the capacity increases. So 120 amp hours, two of them linked together becomes 240 amp hours of battery storage, power storage. It does not increase the discharge rate. The discharge rate remains the same as the one battery's rating, no matter how many of them you have linked together. Now, this is because when you wire up the bank, you have your positive coming off one battery and your negative coming off the other battery. So this means that when you turn your inverter on, the load is still pulling through both batteries at full capacity. It's not taking half of the load from this battery, half of the load from this battery. Now, a 2000 watt inverter at 12 volt will draw 200 amp in 1 hour. These batteries are only rated to 100 amp per hour. And as we said, just because we've got two of them linked together, it does not mean that we now have a 200 amp per hour discharge rate. Yes, we've got 240 amp hours of battery storage, but we still only have a combined 100 amp per hour discharge. So this here is the most common issue that we see. People think, oh yep, I've got 200, 120 amp hour batteries, lithium batteries linked together, bang, stick a 2000 watt inverter on it, surely should be good to go. Not the case. The issue that one of the issues that the owners of this van have been having is that when they do try and run the inverter over 1000 watt, it's actually been tripping out the BMS in the battery. So the BMS is the battery management system that is part of all lithium iron phosphate lithium batteries in caravan RV applications like these. So the BMS is what provides that current limitation. That is what is providing that 100 amp per hour rated discharge. When that's exceeded, the BMS disconnects itself from the cell to protect the battery. So the issue that we've got here is we've got a battery bank that's only useful for 1000 watt of inverter at 12 volt, and someone has gone and strapped a 2000 watt inverter to it, which straight away is a big issue. Okay, so that is probably the number one phone call and issue with lithium power systems with inverters that we get. Second most common issue that we see, cable sizing and fusing. The cable size used for this inverter installation is undersized. Also, the thermal circuit breaker that's been used here, first of all, isn't big enough. It's only rated to 200 amp, and as we mentioned, the 2000 watt inverter at 2000 watt of draw on a 12 volt power system will actually draw 200 amp. So if you were to run this inverter at full capacity, it'd trip that breaker every time. Second of all, the type of fusing that's been used, it's a thermal breaker. Now, we don't recommend using these for anything really. We would much prefer to use a bolt-on mega fuse system for our inverters, as we do with all our installations. They're a solid bolt-on connection and they're not affected by heat whatsoever. They provide a much lower resistance fusing connection. So far, we've got issues with the rating of the battery, issues with the inverter size, undersized cabling, and the wrong fusing. So as you can see, so far, not much good to find, and we're only just getting started. Now we're going to chat through, not sure if you can see, but this here. All right, on to probably the worst part of the system, well, definitely the most dangerous, is how the AC side of this installation has been completed. So currently we've got no RCD protection, so no circuit protection on the output from the inverter, and the inverter's not hardwired into the van or anything like that. It's literally just running a loose extension lead out of the inverter to the outside of the van when the owners are off grid. So firstly, this is only a 10 amp output, and the van is a 15 amp input. So they've literally just used a small length of 15 amp extension lead, grinded the pin down on the inverter side, plugged it into the inverter, and then they're using the other end to plug into the van. As we mentioned, that means that the output from the inverter to the inlet is unprotected. No RCD protection on that section. Obviously, once it is going into the van, it is then protected from the van RCD. But yeah, there's no RCD protection between the output of the inverter and where they're plugging into the van, which is a big safety concern. The other issue you get with that is because you're just plugging it into the outside, it is then going to power up the AC charger under here and create a big power loop. So as soon as you've got the inverter on, plugged into the outside, that's going to power all the power points throughout the van. The AC charge is going to come on and start trying to charge the batteries from the inverter, and it's just going to create a big loop. So what we do as part of all our inverter installations is we have a 240 volt GPO installed that is just powered from shore power and not from the inverter, which means the AC charge is only going to come on when you're plugged into inlet power on the outside, not when you're using the inverter to power the van. The other thing that we do is we hardwire the inverters. So we use an inverter that has an automatic AC transfer switch in it, and this is then hardwired into the van. So when you plug the van in on the outside, it automatically switches back to using grid power. When you are disconnected from grid power and you have the inverter on, it automatically feeds out to everything throughout the whole van. All the power points, appliances, air conditioning, microwave, anything that would work when you're on grid will work when you're off grid, and that's a complete automated process. There's none of this plugging in leads and bits and pieces like that. It's all hardwired. You literally just hit the inverter button, turn it on, and you're good to go. So that is a standard inclusion with all our off-grid power systems, is RCD protection, a hardwired GPO power point dedicated for the AC charger, and automatic switching between on-grid and off-grid power. Also, another big one that's a standard inclusion with all our power systems is an updated 240 volt electrical safety certificate, which is really important for your compliance and insurance, which I can guarantee did not happen with this one because it is not compliant. So really, we've only just touched the surface of some of the issues that are going on here. There's quite a number of other DC issues that are happening throughout the system as well that we are going to rectify, but we just wanted to cover off these main few, mainly regarding the inverter side of things and the battery discharge rates, because they are definitely the most common ones that we come across. So once again, we just want to stress the importance of why we strongly recommend getting a professional to assist you with designing your power system, supplying all the components so they are what you need, and also, most importantly, fitting it professionally, because as you can see here, we've got layout issues with how the system's been designed, which has made it hard to get everything done properly. We've then got issues with products that have been supplied that aren't fit for purpose. They don't have RCD protection. They haven't used an inverter that has RCD protection. And then obviously big issues with how the system's been fitted. So this is why here we take care of the complete design, supply and installation process from start to finish, to make sure that we get that whole process right and correct and everything runs smoothly, and most importantly is safe. So that is why we not only recommend getting a professional to take care of this process, but specifically finding someone like ourselves that specializes in off-grid power systems. Now there's people all throughout Australia, businesses that specialize in this area. If we aren't close to you guys and we can't take care of it, then we can definitely recommend someone else in your area, because at the end of the day, if we can't take care of the process for you, the best thing that we can do is make sure that we send you to someone that will look after you and do the job correctly, because at the end of the day, that is what we want to see. We want to see safe, reliable power systems and not stuff like this that is putting people at risk. Honestly, this one's a bit of a mind-blowing one. And like we said in the beginning of the episode, to think that this is under a kid's bed, it's just, yeah, takes your breath away. But the most important thing is that we have got onto this before it's caused the owners any major issues, and we are going to get everything here resolved, and we will do a follow-up episode once we have this system completed to show you the difference in not only how the system looks and runs, but we'll also talk you through how the system works as far as that auto transfer on and off grid, the RCD protection, and how the system functions with the new inverter. Well, that pretty well wraps up this Tech Talk episode, guys. We really hope that this one has been helpful for you guys to see why we strongly recommend engaging a professional when it comes to putting your power system together. If you do have any questions regarding anything you've seen in this episode, please drop them in the comments section below, or reach out to us via email and we'll be more than happy to help out. As always, guys, thanks again so much for tuning into this episode, for supporting the channel, and we'll see you on the next one.